Hello everyone, it's your TA Cam yet again to bring you some more electronics discussion. Now this is part 2 of our series on videos on how to get you up and running with using the Node MCU v3 and programming and controlling your own little, sensors and devices. Before we go ahead and start using this and connecting all these devices together, we do have to set up our computer in a basic level in order for this to be able to communicate with our computer and for us to be able to write code and send code and upload it to the microcontroller here. So the first thing you're going to want to do is install two pieces of software. We're going to start by installing the Arduino IDE, or Integrated Development Environment, as well as the drivers for the CH340G chipset, which is on here. It does tell you that on the back of the actual device in case you don't watch this, but let's go ahead and walk through this together and get you all set up. First thing you're going to do is navigate to the Arduino website. You can Google Arduino, or you can go to arduino.cc. From there, go ahead and click on Software and Downloads, and scroll down a little bit to find the download links for the IDE. Now, of course, depending on what OS you're on, you can go ahead and choose your correct installer. I'm running Windows 10, so no biggie for me. I just hit Download, Install, and when I'm installing, and this goes for whatever OS you're using, please ensure that you install all dependencies and drivers that it prompts you to install. This is important so we don't miss out on any sort of software bits in order to get this up and running. After you've done that, and before you open up the Arduino IDE, and plug all of this in, we're going to have to download the CH40G drivers. You can do one of two things. Now, obviously, you're going to have a document with all this information, so you don't have to type all the links that you see on my screen really quickly. But after you've done that, go ahead and either Google CH340G drivers and click on the first link, which takes you to a sparks.gogo.co.nz website. Otherwise, you can just click on the link that I've provided and go ahead and get to this website in the same manner. Now, similarly to the IDE, you're going to have to choose the drivers that are appropriate to your OS. For me, I've just go ahead and downloaded the Windows driver and installed it. It's very straightforward. You unzip, run the installer, press install. Nothing really earth-shattering to do. For Mac, you'll have to install a driver package, and for Linux, most of the drivers for these chipsets are already included, so you don't have to worry about it. Another reason why Linux is so fantastic. If you're having any trouble with the installation of either the Arduino IDE or the drivers for the CH340G chipset, just let me know, and we can talk about it during office hours or during consultation hours. So now you've gotten that installed and set up, you're going to go ahead and open up your Arduino IDE. So now that we've opened up the Arduino IDE, we're presented with a blank sketch. Don't worry, a sketch is just Arduino's way of referring to a bit of script. Arduino will use a C-like programming language, so if you're familiar with C, it's very straightforward. If you're not, don't be intimidated, it's genuinely not that bad. We're not going to go into super in-depth programming here, and most of the work is actually done for you. There are other things to do when we're starting to deal with sensors, like this little RGB light sensor that you're given, that involve the installation and the use of libraries, or packages of code that you can use instead of having to, recreate the wheel and program your own little bits of functions for this. Rather than doing that, you're going to have libraries take care of that for you. However, that is beyond the scope of this video and will be talked about in the next video when we assess all of the little sensors that you've been given. The first thing you want to do before you plug this into your computer is to download the specific drivers for this board so that Arduino can recognize the Node MCU v3 and not think of it as some generic device or an Arduino when it really is not. So there are two steps to perform. First, you're going to hit File in the top left-hand corner and go to Preferences. At the bottom here, you'll see additional Boards Manager URLs. I've gone ahead and pasted this in already. This will be provided to you in the same document with all the download links for the IDE and the drivers, so don't worry about pausing and copying it in, but ensure that you copy it in and hit OK. Afterwards, you're going to go to Tools, Board, and then Boards Manager. What you've done is you've added a library for the Boards Manager to download. So if you scroll all the way to the bottom, you'll see the ESP8266 community package. Go ahead and select the newest version from this drop-down menu and hit Install. That'll install all the necessary drivers and sort of little bits of code within the Arduino IDE for you to be able to use this properly. If you do not do this, you will not be able to use this, so this is very critical. After that's been done, we can go ahead and scroll down to Board, scroll to ESP8266 boards, and select the Node MCU 1.0 ESP-12E module. That is our chipset that we're working with. Prior to doing anything else, we also have to make sure we've selected the right COM port. However, you'll see that I only have one COM port and I don't have this plugged in. So now would be a fantastic time for you to take your included micro USB cable, connect it to the actual device, and then plug it into your computer. In doing so, you'll hear a little chime that you've connected a new device, and you'll see a new port come up. And see, I now have COM4 selected. If you have multiple COM ports being shown up here, don't worry about that. Just try one and then try the other if it doesn't work. It should be relatively obvious. Or you could do what I do and plug it in and see which COM port pops up, and that'll be the COM port that corresponds to this device. Now that we've gotten this connected and established, let's try to upload some code onto it. This is more or less kind of useless right now because it's not running any code. It doesn't have anything on it. So let's set up a quick sketch that just causes the onboard LED to blink. So if you go to File and go to Examples, you can scroll down to the ESP8266 section and select Blink. That'll open up a new script for you, and you'll be able to look over it and just get an idea of how it works. Without going into too much detail for now, every sketch has two main functions. We see that there is a setup function and that there is a loop function. The setup function runs only once and at the beginning, which means that if you plug in and give power to this thing, it'll start running that script. It'll run the setup method first, and then move on to the loop method. And that will just run over and over, hence the name loop. To give you a little bit of a breakdown about what the script does, you can either read the comments or I can explain to you briefly. In the setup, we're using a function or method called pin mode to say that we want the built-in LED to be set as an output. That's our setup essentially for the script. And during the loop, we're going to do two things. We're going to use the digital write method, which now accepts two arguments, one of which being which pin to set as a digital write pin and what parameter to set it to. In this case, we're turning the built-in LED pin. These pin values and sort of definitions will become more obvious as you work with this. So there will be more information to understand that as you continue, so worry not if you're a little bit lost at the moment. Afterwards, we're going to delay the system for 1000 milliseconds or 1 second. After that, we're going to use the digital write method again to ask the built-in LED pin to be set to high, meaning that the voltage is set to high. It'll turn on. And then we're going to delay for 2 seconds and rinse and repeat the process. So what's going to happen is we have a 1 second wait, and then the LED is going to turn on for 2 seconds, and then there's going to be a 1 second wait, and then the LED will turn on for 2 seconds, and so on and so forth. If you're not familiar with a lot of the programming languages being used, don't worry, because as time continues and you develop your own little sketches for the modules that you're using, you'll have a better understanding of how to use C or the Arduino language to create sketches for your board. First thing we want to do before we upload this, now that everything is connected, is we're going to hit verify. And as you can see, it's going to do some compilation and make sure that everything is okay. We're getting no errors, and we're telling us that this particular sketch will take 24% of our onboard space on the chipset. Let's say I, for example, just type in some nonsense into the IDE. When I go hit verify, it's going to throw me an error when it gets to this point. It says this thing was not declared in the scope. Basically what it's saying is the IDE has no idea what this is, and it's not going to let you compile it. Okay, so now that we've sort of fixed the error that we've intentionally introduced, we're going to re-verify the sketch, and afterwards hit upload. This is the process of uploading the actual sketch to the IDE, and you'll see that there's some sort of messages that you receive. Don't worry about it so much, but at the bottom you'll see that it's writing your code to certain memory addresses, and you can see the percentage of which it has written. If you're looking at your board, you'll see that there's a blue LED very faintly and very quickly flashing. This means that it's being flashed with your particular sketch. Afterwards, you'll have your newly installed Blink sketch running. And you'll see here, the LED has turned on. It's a second delay, and then the LED is on for 2 seconds. Second delay, 2 seconds. So, very simple, very straightforward. You, as a new Arduino scholar, should take the time to play around with this code. For example, you can set the delay values for both of these to 500, so there'll be more rapid blinking. I'm going to go ahead and verify that, and then I'm going to hit upload. Fantastic, we're at 100% now, and look at that. It's blinking a lot faster for a briefer period of time because we've adjusted the delays between our methods used to adjust the digital write for this particular pin, or in this case, the built-in LED. Now, a lot of this might sound foreign to you, as I had said, but don't worry, we're going to get you up to speed quite slowly. Now, a lot of this might sound foreign to you, and if you're worried about that, you shouldn't be, because as you learn with time and experience, this will become sort of second nature. There are a few things I want to talk about quickly. First of all is the idea of methods or functions. Now these are already pre-written for us and denoted in orange within the IDE. And this pin mode, this digital write, this delay, these are all methods that are already contained in the IDE that do something. A method is something that does something, and oftentimes you'll have to feed in some sort of arguments or commands into the method. In our case here, we have two arguments, the pin number and the setting, or the fact that we're setting it to an output. This might not be entirely intuitive, and it shouldn't be, but this is where reading the documentation for either your Arduino or your different sort of boards that you'll be using later on, especially in the case of using libraries, will come in handy. I'll give you some resources to look at, and honestly, it's not as difficult as you might think, but again, if you're getting stuck, if you're having a little bit of a mental oopah when it comes to understanding some of this, just write me an email and we can talk about it. It's really not that bad, and I want to prove that to you earnestly. So that's it. You've got up and running with your new Node MCU V3 chipset. It's plugged in, it's doing blinking for now. Next thing, in the next video, we're gonna connect this to a bunch of these sensors, install some libraries, and start designing some fun little experiments to use these for. So you can hopefully use these in, your own little experiment at home. So thanks for watching, and I'll see you in the next one.